This is Harry Ronitz. What you are looking at is a primitive motor that consists of a field and an armature assembled from some kit parts. And we will be using that to demonstrate a couple of principles of electromechanics. And this is one of the parts in a bigger arrangement. Here we have the battery, and here we have an oscilloscope that we will be using to demonstrate our points here. The first point, if we look at the bottom there at the of the field, we see that there are coils of wire wrapped around the metal, and that, according to Ampere's law, when we pump current through those coils, will generate a magnetic field. And the metal material is a material of relatively high permeability, and therefore we can direct that magnetic field to be in space where we want it to be. And so what we want here is to have a north pole, that would be our left pole, and then our right pole would be the south pole. And so we will have a B field going from left to right. The next point is that the armature, which is movable, is currently in the position that it would be in when current can flow through it by way of the commutator. You see, the commutator allows for the conduction of electricity when it's in this position. When current flows through that armature is in the middle of that B field, so current flowing through a B field will generate a force. By the right-hand rule, the force on the right side of that armature will be directed downward. The force on the left side of that armature will be directed upward. So we will have a net torque trying to rotate the armature clockwise. And this will start to happen after I connect the battery up. So that's what I will do now. Try to keep the camera on it while I do the connection. Okay, nothing has happened yet, and that's because the armature is not in contact. I have to give it a little twist. There we go. It's beginning to pick up speed a little bit now. And what I will now do is direct your attention to the oscilloscope. And the point I want to make there is what we are looking at is the armature voltage. And you can see the spikes, brief spikes that occur. It's beginning to speed up some more now, and so you can see the period is decreasing. But those spikes are the back EMF as the voltage is being pushed through the coils. Here it is at a higher speed. Oh wow, it's really taking off now. Okay, I'm going to stop this part of the demonstration and direct your attention to this other apparatus, which is the second point of the demonstration. What we are looking at here is a MOSFET. We're going to be using this MOSFET to control the motion of this motor. The underlying principle that we will be demonstrating is Gauss's law. That middle terminal is the gate of the MOSFET. We will be increasing the voltage on that middle terminal, and as we do so, we will be accumulating positive charges on that middle terminal. As positive charges accumulate on that middle terminal, by Gauss's law, the electric field intensity around that gate will increase. As the electric field intensity increases, it will draw or attract electrons into the P material of the gate of the MOSFET. As those electrons are drawn in, at first all they will do is fill the holes of the P material, and then later they will become, as more are drawn in, they will become mobile electrons, which will allow the conduction of current. So we have to increase the voltage sufficiently to get the mobile electrons into the gate region of the MOSFET. We will be using this apparatus here to increase the voltage on the MOSFET. This is a microcontroller which will generate 8 bits of digital output, and then that 8 bits of digital output will go into this digital to analog converter, and then that output will go to drive this gate. We will monitor the gate voltage here while we are watching the motor and watch what happens when it meets the threshold voltage. So at this point I will turn on the microcontroller to get it started increasing voltage. So now we can watch both the motor. There we go. We're at 4.6 volts on the gate, and the microcontroller will continue to increase the voltage, and notice it just suddenly kicked on. So that we suddenly met the threshold voltage, which allowed enough electrons into the P material to become mobile, and now the motor can turn. Thank you for your attention.